in our outside corner piece, the C-channel was set down almost touching on the inside. So there's a gap on the outside of the track, but the inside is almost touching. You have to leave just a little space, which you'll get to see as you come up and walk up once we get this all braced up. And he's going to put his corner panels onto that outside corner. And our corners, in the plastic corner like you see there, we make that in a 45 and a 90. If we can make any custom corner angle, it just wouldn't be in a plastic corner, then it would be a full polystyrene corner. And then that, again, we can make any angle that's needed, 22.5 degree corner, whatever. For a project, we can make those custom angles.
The corner panels are designed to fit nice and tight, so they stick together.
And we want it all, the whole corner itself, each component as it's going together is designed to fit nice and tight, so it's not falling apart on you as you're building it. There's a couple of ways to build the corner. You can build it right in place like you see here. Sometimes it's easier to build on a flat table, down on the ground, and then set it up. What happens is, as you build our system, everybody kind of gets their own little technique and their own little groove of what they like to do. And there's 10 ways to do almost everything. We try to show what we've found over the years to be the easiest, but it doesn't mean it's the only way. So then our stud, or that ladder, of course on the poly panel, it's going into a groove of the poly. That groove is a 1/2 inch in from the face. And then on the plastic inside corner piece, by design is made again to click in there a little tight. It is a plastic component. Sometimes it can be manufactured a little bit less tight. And sometimes they are just like they're supposed to be right here and fit real nice. But if they do get loose, there's little holes in our stud that you can see through the side right in each cross tie area. You could always stick a little screw right through there to hold into the plastic stud if for some reason that showed up and it was just a little bit loose. And then what we do is set the corner up like this, build out a little bit, and then what Jerry will do is come back and put in his corner rebar right away. We put the corner rebar in right away before we get inside panels on, so we have enough room to jockey those studs or ladders around so that the legs will get into the form. So when you put the corner rebar in right now, real easy, obviously. We just put a panel on the outside, another stud, panel, stud. Building straight wall with our system is really fast, really easy. You can get carried away real quick with just building straight wall and not bracing anything. And one of our enemies in this world of ICFs is wind, of course, because it is a light form. So it's hard to kind of slow yourself down from just building out 30, 40 foot. If there's not any wind on site, then fine, no problem, you can do that. There are ways that we wind brace it as we build before we get bracing on as well. But we like to promote build out through 10, 15, 20 feet and then throw a brace on. Yes, question?
Is there a certain amount of rebar that you have to put? What spacing?
Another rebar question. The question was, is there a certain amount of rebar you have to put in and what is the spacing? Yes, there is a certain amount of rebar that you have to put in, but again, the spacing is dictated by the application. The changes depending on the height, the thickness of that concrete wall, where is it going, but those are all questions that we can help with on a residential side because there's already a code out there that we can open up and show you based on these tables, here's exactly what you need. On the commercial side, do we have any commercial guys that are potentially go? Okay, on the commercial side, most projects are engineered already. So the engineer is going to tell us what's needed in that wall. So Jerry's putting a screw right in through the C-channel into our plastic corner. We do that right away as we set up this much wall just to help hold that in place and keep it right where it's supposed to be on the bottom of the wall. And again, remember that C-channel is attached down to the footing. And one thing I did not mention is we only attach our outside C-channel. We don't attach the inside. We let the inside one just float. The reason that is because if we would go ahead and attach both C-channel and we didn't attach the inside one perfectly where it's supposed to be, even if it got off 1/8 of an inch, those studs are always the same. So if I nail that inside track off just a little bit, I'm going to struggle getting those forms into place. So that's why we let the inside one float. We only need one side attached. That's plenty to hold the wall in place. The only time we attach an inside C-channel is where we have an inside return corner. So if I have that big section of the corner with the corner legs on the inside of the wall, because I have a little bump in my project, then I'll just attach just off the corner a little ways to help support the bottom of that big corner. Yes?
How much do you overlap the C-channel?
Good question. How much do we overlap the C-channel as we're building? On the footing, we'll only overlap the C-channel about 2 inches, just enough to get a nail or fastener in that overlap. When we go to the top of the wall, that C-channel overlaps more like 1.5 feet. And the reason we do that is because that C-channel is what we call our whaler. So on a regular poured wall form, in the concrete world, you'll see whalers or horizontal whalers, 2x6s or 2x4s, whatever, on the wall. We don't require that because we have that C-channel on top, and that is our whaler. So we'll overlap it just for strength purposes. It'll help keep that wall from wanting to move in or out. Once we put that corner rebar in place, it is nice to put a tie on it. A lot of times there will be vertical rebar coming then out of your footing or your slab. And we'll tie that corner rebar either to the verticals, or we can tie it to, in the corner, we can tie it to our stud or one of our cross ties. What we don't like to promote, whenever possible, not tying the rebar to our tie unless you have to, just because with our system, there's some really cool things that we can do with it. You'll notice, we'll get into as we're building, we'll show that we can build open wall. We can slide the panels up to have access to the inside of the wall. If I go, and then there's things like if I start tying that rebar to my studs before I have this corner braced, then it's hard to jockey that thing back to get it straight because the rebar is catching on the studs and the ties and just not allowing me to move it very easy. And if I want access to the inside of the wall to put my verticals in and things, it's again, if your horizontal rebar is tied to your stud ties, it's just hard to move those around. So again, if you have to, no problem. Or once you've built past the section that you know you're not coming back to, then you can throw a tie on our stud. But it's nice to tie that horizontal rebar to our vertical rebar. So Jerry's throwing another screw on the inside corner, mainly here just to hold it because we're going to actually take this and slide it out. So there's very little screwing needed of the form system to the actual track. On the top where we overlap that C-channel, we just use those little steel stud darts. Again, we're just screwing C-channel to C-channel. We don't have to go ahead and screw it all over the place to the form. It's sitting up there as the guide, and it performs fine without being attached to the forms. The only time we start screwing C-channel to the form is if our footings were off, or we're trying to adjust heights a little bit. You can lift up on that C-channel a little, send a screw into the stud, or all the way through, and then you can play with that height adjustment and use the C-channel to do that. Yes.
With the overlap in the C-channel, you know how you put size on size, one is the bottom, one is the floor, does that give you an issue, especially at the top, when you start overlapping the foot?
We'll show you. It actually, with our track, it overlaps itself pretty well, but you do get just a little bit of push out on the side, or you can. So if for some reason it's an issue for the project, we haven't found it to a reason. You know, maybe somebody's doesn't want it to be in the way of the drywall or it's pushing out a little bit too much. Then you could send a 3-inch screw through and pull it back together. The biggest reason we don't send 3-inch screws through the C-channel on top, or very rarely, is because then you have it sticking in to the inside, and if somebody goes up there and grabs and doesn't know that screw is in there, then you can get cut out pretty quickly. And, so that's the main reason we don't do it.
those that see that poly panel come apart, this is just a little helpful aid. Typically on a job site, you're not spinning around, so you're not worried about coming apart. But as you're building the wall, if you want, you can hook these on, and it keeps everything together. It keeps your wall running perfectly 8 inches outside the top. That's the number one thing.
The number one thing, we'll get into a couple of tips and tricks as Jerry's building here, but that component right there we call a lateral tie. So it connects our studs together. That doesn't automatically come with the form system, lateral tie, because it's not needed. But for newer guys building with our form system, it's very helpful to help build straight because it's keeping every stud at the correct spacing. Now those lateral ties, of course, if it were an 8-foot wall like this, you could put them in, then you could reach in and take them out after the wall is up because they're no longer needed once you build past that section. And if somebody wanted to reuse them, it's a pretty cheap part if somebody wants to use it. There is one system that we sell where we use all 2-inch foam, and our Habitat guys here know about it. You see the blue Dow foam over there. That system requires the lateral tie, and so that does come with the system because of the 2-inch polystyrene. And we'll show that, why it's used and where and how as we build.
Anybody in the crowd interested in coming up and put some pieces together? Anybody's not shy yet?
Anybody want to put any pieces together now? We will also have at the end, we'll have a station on the end where you can, anybody that wants to play with the forms, you can either build off of the wall that we have up, or we can put some walls up against the regular walls here as well. So there'll be some opportunities to bring up the parts and play with them.
I point at the little guy because it's funny when I get on job sites, contractors, also the little kids start grabbing parts, and they just have so much fun putting it together. And they get to go back to school and say, I built the wall.
When we're building a wall, you should be able to build our wall real nice and straight as you're building before the corner brace is even on. There is a little bit of a trick to it when you're building. It's real easy as you're putting our forms up to want to kick the bottoms tight because you might see a little gap or something on the bottom. The problem is you can kick a whole lot harder than you can push with your hands. So if I'm going along and I keep kicking the bottoms of the wall, I'm going to start to stair step the top towards me, and it's just going to build not level, and then it just makes it a pain when you go to put your last splice piece in at the end of the wall. So keeping an eye on just building nice and straight and flat is key. It really, especially if we have tall walls, we can build our walls as tall as anybody can design them. We poured, I think 35-ish foot tall was our tallest pour in one concrete pour. And I know we're quoting some 50-foot tall stuff right now. So the height is limitless, but the taller I get with a wall, even a 12-foot wall, 14, 16-foot tall wall, it's really key to make sure you watch as you build, to just keep building it nice and straight and plumb as you go. You can always go ahead and throw a level on after you get down 15 feet of a wall, and then get yourself back on if you're for some reason getting way off. But the most important part is as I build out 10 feet each way to get a corner brace on, and then before that corner brace goes on to just keep it plumb. Once the corner is on, now you have something nice and solid to hit against when the 2x4s go up. And of course it makes it a little easier then. So Jerry's going to show the 2-inch poly panel going in place. So again, like I had mentioned, we can go all the way down to a 2-inch panel if a customer were to need that or require that or want that for whatever reason. Again, 2 inches is the least we can go down to because it has to hold concrete pressures, and 2 inches is all we can have, the lowest we can have. Question? The question was, we have all the 4 and 5 foot. If we have a real tall wall, could we go with like a 10-foot panel? Just like you see on that corner panel right there, that is hot wire cut, we do have the ability to make we can make panels up to 10 foot tall if we need, for some reason, a full height or full tall panel like that. It's just, we've done a lot of time studies because we actually use, all our panels used to be hot wire cut like that and not the 4s and 5s. And so every one was, like if I had a 9-foot wall, it was a 9-foot panel, an 8-foot wall was an 8-foot panel. The extra time it takes to stack the two is extremely minimal, very small. But what we gained, the reason we made the change, was we gained several things. We gained the ability to have bunks of 4s and 5s that are much easier to move around on site. We gained the fact that having 4s and 5s that conform to all different heights is a lot better for leftover components for the next job. Because now I didn't have a 9-footer, well now my next job is 10 foot. You know, so a 4 and a 5 having it on stock or in stock just covers a whole lot more wall options. There's an electrical base that we'll get into that's built into that 4 and 5 foot panel where they come together. And then also when we get to tall walls, a lot of times we want to break them up anyway. And even in a traditional situation, if I had a 20-foot wall, on one side I would have in the past put 2 10-footers, but then on the side that I'm going to pour on, I would have had 4-footers anyway, or 5-footers, whatever, to make up the difference, because then we pour through the side of the wall for our tall walls. We don't want to drop concrete for any higher than 12 foot, because then we start to get concrete separation and pressure build up on the bottom of the form when we start dropping higher than 12 foot. So we can slide up our panels, pour right through the side of the wall for our different levels, and that's how we're able to do like our 30-some foot tall wall pours. So we were stacking them anyway in tall wall scenarios, and so it just made sense in a lot of ways to switch to that 4 and 5 foot. But if you want it, we certainly can do it. Question is, how do we integrate this basement pour into our next height pour or above grade wall pour, maybe, let's say. What we do is we stop at the top of a floor level. So if I'm doing a foundation, but I'm going to come back and do my above grade wall on it as well, I will stop that foundation wall at where the top of my flooring would be, depending on how I'm digging the ledge for my floor. We'll go through floor ledge connections. Most of the time the floor is hung from the side of the wall with different connectors that are available. So if I want 9-foot headroom and I have a 1-foot floor system, I'm pouring a 10-foot concrete wall, putting my floor in. Then now I have C-channel on top of that wall. Now I'm going to come back and put my upper walls on. So I just flip my C-channel, instead of it being a top gap, now it's a track again. And I screw C-channel, and go right up to the next level. That's if there's a floor system breaking that wall. If there's no floor system breaking the wall, then I'm just going to build a tall wall all the way up. But if I do have a floor system breaking the wall, we don't tend to do, some customers go ahead and pour 2 levels at once with the floor system in on job site, but most typical is not doing that. You pour the 1 level, then set up your next level, brace right off the floor system. Otherwise, if I go all the way up, a lot of times I need tall wall braces and things, and it just slows you down, actually, trying to do it all over. Yes. Yep. In commercial applications, a lot of times we do that. And you'll see some pictures pop up on the screens of some projects where we've done that. One that comes to mind is the Fastenal building that one of our customers did. It was a 16-foot tall wall. So we actually made 16-foot long studs, stood them all up, but it was really, really, really windy when we did that job. So we just set up 8-foot panels, poured them, but left the 16-foot studs sticking up. So then, then you just went by on the next level and slid all the panels down. Above grade, I can have a cold joint in the wall, so I don't have to pour all my concrete above grade at one time, like in a commercial setting where you have several 100-yard pour, and you can't get it all done in a day just because of time and that amount of concrete. You can have a cold joint, because you have rebar, things that are bridging that cold joint.
For any reason, could you have a vertical cold joint?
Yeah, absolutely. We have vertical cold joints all the time in our big commercial projects, whether it be apartment buildings or hotels and things. We'll just shut off the wall and we'll make basically like a tongue and groove shut off, just like any regular poured wall guy would do with a 2x4. We have some really good ways of doing it where we leave the rebar stick out and switch a 2x4 in there. But absolutely, we could have a vertical joint or horizontal upgrade. Yeah, above grade. Key being above grade. Below grade, you cannot have a cold joint because that will be an area that water will get through that wall. Water will leak through if it's in a wetter area. Of course, if it's real dry and sandy soil, you might get away with it, but strength-wise and water-wise, you can't below grade.
Have you seen where anybody switches to the 2-inch foam for like a electrical chaseway?
Yeah, there are some different applications for switching foams, like you're talking, and we don't see a lot of people doing it, but you certainly could. So, like that wall right there would be no problem with pouring that concrete in that wall and it holding just fine with switching different foam thicknesses. But there are some tricks that we do have for different chases, and we'll get into the electrical side of it and how we create grooves for electrical and plumbing and things. And most common with a hot wire or a hot knife, but there are several other ways too. But there's a lot of little details that we talk about or tell our customers about, especially when you're doing a full concrete home or commercial structure, above grade concrete. There are certain little things that come up that you want to think ahead because it is concrete. But we help with a lot of those details for customers that aren't familiar with that. Thanks everybody for helping build the wall. So what we do is build out about 10 feet each way, and then we go ahead and throw our corner brace on. The corner brace is the most crucial